This is Unit 6, Section 6.1, looking at and reviewing some basic area formulas. So this will kick off our unit, and now we're into more of a typical unit. So we've just had Unit 4 and Unit 5 were kind of mini units. Now we'll do our couple sections with a quiz, another couple sections with our test. So in this one, we're going to find the area of many different objects. These are formulas that you've had from 3rd grade, 4th grade, and on. So we'll be reviewing those as well as applying them to maybe some more hour level applications. So when we look at the first one, we have our rectangle, which maybe we've seen as that formula as length times width. Square, we have area, which would be side times side, which is side squared. And we've seen these two before. What I want us to start thinking about is a consistency, because when we get to parallelogram, the formula for a parallelogram is base times height. So the base, and it doesn't matter because the bases are the same, times height, which is always perpendicular. So even though this is what I would call a lazy rectangle, where it's kind of slanted or leaning, the height is always measured base to base. So when we look back at the ones that we've practiced before, I want us to change this. This can be considered a base, and this can be considered the height because it's perpendicular base to base. So if I change that, now I have base times height for rectangle. And while yes, square could be a special formula, if we change this to base and height here, now we have a way to find the area of any four-sided object here when we have two bases that are the same. So we can change this also to base times height, so that the rectangle, the square, and the parallelogram aren't their own individual cases. They're all base times height. Which then, as we get to triangle, every triangle is half of a rectangle. So we take base times height and divide by 2. Because if I went like this, do you see the other side of the rectangle? This would be base times height, and then I would divide by 2 to just get the triangle that's left over. When we look at a trapezoid, this is our first time where now we don't have two bases that are the same length like we did on rectangles, squares, and parallelograms. A trapezoid still has two bases connected by a height, but these bases are now different lengths. So what we do is still this base times height idea, but what we're going to do is take base 1 plus base 2 and divide by 2. Okay, this will find the average base so that it'll measure here instead. We want to not use base 1 because that would be too small of an area. Base 2 would be too much of an area, so we average the two to find the middle. That's just right. The height then is multiplied to get the area. So now we have to do a little manipulation here to find the base, but it's still an idea of base times height. So rectangle, base times height, parallelogram, base times height. Triangle, we have to remember to divide by 2. Trapezoid, we average the two bases to find the middle one so we're not too short or too big. Circle is now we're moving to a round object here, and the area formula for this is bringing in pi radius squared. So D is the diameter all the way across going through the center. R is the radius going from center to edge of the circle. So we want to make sure that in our formula, we are using the radius R. Most of these formulas you should have seen before, even if they're in your brain and a little dusty, we're going to practice by applying these formulas. So the first thing that I want us to go through and look at is identifying the figure and then find the area. So when I look at this figure, I have 8.5 by 8.5, which makes this a square because those measurements are the same. So to find the area, I'm going to take base times height, which is 8.5 times 8.5. And when I multiply those together, I get 72.25. And my units here are not feet, but feet squared, because that means inside of them there are 72 little squares in here that would fill the surface of this square. On number 2, this object is a triangle. So our formula here is base times height divided by 2. Okay, we have a base, 15, times a height. That is our perpendicular height. We never want to use a slant. So they're marking that with that perpendicular marker. And divide by 2. And then I go straight to my calculator. So 15 times 21.3 divided by 2, I get 159.75, and this is going to be measured in meters squared. So we are going to be looking for those correct units here. So if you have questions on how I'm getting those, let me know. On number 3, this is going to be, okay, I have the same base, but it's not a rectangle because it's kind of slanted here. So this is our parallelogram. And our formula for parallelogram is base times height. Okay, so my base here is at 12.9 times my height here. There's my perpendicular right angle height. I never want to use the slant height, so I get 7.1. So in my calculator, 12.9 times 7.1, and I get 91.59, and I'm going to measure this in inches squared. So inches squared means that there are 91 little squares that would fit in here that are inch by inch. On number 4, this figure is a circle, and our area formula is pi r squared. Okay, so the 26 they gave us is the diameter. It's all the way across. So what I'm going to do is divide by 2 to find the radius here and here, splitting it into 2 radiuses, so that I can apply my pi 13 squared. Now when I put this one in my calculator, it comes out to be 169 pi, which is approximately, if I use that toggle button, I could say this is 530.9, and I would then say, okay, our units are yards squared. Either one of these is appropriate because they haven't asked us for an exact answer or told us where to round. So if they said I want an exact answer, we would have to leave it as 169 pi. If they said to approximate or round to the nearest tenth, the 530.9 would get us the same value. On number 5, okay, so these are not the same length, so this must be a trapezoid. So bases are not the same length, so our area formula for that is base plus base divided by 2 times height. All right, so our base, we have one base that's 19. We have another base that's 27. Divide that by 2 and multiply by the height. Okay, well, we have 3 values here that are going base to base, 16.5, 16, and 21. We want to use perpendicular height here. So we're going to multiply by 16 and not use these distractors, 21 or 16 and a half. So when I multiply those two, 19 plus 27 divided by 2 times 16 in my calculator, I get 368. And my units are going to be centimeters squared. So 368 little square centimeter by centimeter blocks could fit into here. On number 6, this is a rectangle. All 4 corners are 90 degrees. The area formula is base times height. So I have a base of 3.7 times a height of 10.5. And so in my calculator, I can put those together and I get 38.85, and my units now are kilometers squared. So our basic shapes are just kind of a review that we've done these for a very long time. Trapezoid, parallelogram, circle kind of need some dusting off. Number 7, we have a triangle here. And notice again, these are not part of the figure. These are dashed lines that are saying, okay, this helps us know the measurement out here, but it's not part of our figure. For a triangle, we do base times height divided by 2. So in this case, we have a base of 29.5 times a height. That's why they gave us this 14, because we need that perpendicular to the base height. So this 14 is the height of that triangle, no matter where I drag it across here. okay, it would still be that height from base to the very tallest it is. So we're going to say that one is 14 here, divided by 2. So when I put that in my calculator, I get 14, oh, okay, forgot to write down triangle here. And the area from my calculator is 206.5, and that is in inches squared. Number 8, I have a parallelogram. And the area of that is base times height. Okay, so in my area, I'm going to have a base of 11.8 and a height. Okay, so I have 2 heights given. From base to base, I have the 18.5, or this kind of auxiliary line is what it's called when it's dashed, 16.1. Again, I'm looking for that perpendicular height that would tell me the distance from base to base, no matter where I dragged it across. Base to base, here's my height. So when I put this in here, I'm going to use 16.1 as my height of this parallelogram. Multiply those together and I get 189.98. And my units are going to be meters squared. On number 9, okay, this one's different because this is not the whole circle, which actually me tracing is pretty close. This is half a circle. So what I'm going to do here is take our pi r squared, which would be an entire circle, and divide by 2 to just get half of the circle. And this is kind of what we're going to be exploring in our next section as well, or parts of circles. So in this case, we have half of a circle, or a semicircle. So we could say half circle, which also is called a semicircle. And so when I fill this in, I have my pi. The radius they give us is 17, so I replace r with 17, and then half the circle, so I divide by 2. When I put this in my calculator, I get 289 pi over 2, and so this would be the exact answer because I haven't rounded it, which is approximately, so again, use that toggle button right above enter. And this would be about 400 and, I think it's 53.96, and that would be feet squared. All right, on our last one, okay, that base isn't the same as that base, and we have perpendicular here. Bases aren't the same this way, too. So when we're picking the bases for a trapezoid, we want to make sure that we're picking the parallel sides as the bases. So when we had this one, these were the bases that were parallel. So that's what tells us which ones are the base, even if this one has been rotated to sit here. Bottom doesn't always mean base. These two are parallel. So when we do our formula of base plus base divided by 2, all times height, our bases we're going to use here are 7 and 13. And the height is the perpendicular distance, and that's why they gave us this measurement, to distract us, not using 9, but we want 5 as our overall height. So then when I put this in my calculator for the trapezoid, I get 50, and this is small, millimeters squared. So in our 10 examples today, we looked at those basic figures. And these basic formulas and figures are going to be the building blocks of everything that we do in these next coming sections. Let me know if you have any questions on the practice, and I hope you have a good day.